we're here as a panel. We haven't done many panels at Spring One. And the goal here is to be a little bit more interactive. So again, first rule, if you have questions, if you have thoughts or feedback even, just throw it out, We'll repeat the question one at a time, of course. Some civility is appropriate. I want this to be about sort of the real world experiences, and that is definitely why you guys are here. You guys represent the real world. These four gentlemen on stage definitely represent the real world. Starting left to right, my left, your right, or is that right, is Dan Webster from Ticketmaster. Say hi, Dan. Rodney Barlow, also from Ticketmaster. Do you guys want to say what you guys do or why people should care? Just who you are, quickly.
I'm the director of the program that does mobile APIs.
OK.
I work on our mobile API team, our platform team, and mobile teams as well.
Do we have a microphone for these guys? Just one? Anything? Just something we can share? Yep, OK. This is going to be good. You're going to get my sweaty love of Ali. Oh, awkward. OK, pass this around. We're having
amateur hour here.
Yeah, seriously, having trouble scaling out the panel, but we can scale everything else, so just don't worry. Right, so while they're doing that, that's Rodney. This is Cameron. How do you pronounce it? Fieber?
Like Bieber.
Oh, it's so wrong.
I'm a software engineer at Netflix. Our team kind of builds all the continuous delivery and deployment tools that everybody uses to deploy all the other Netflix to the cloud.
Louder. Go ahead and mic up, or keep that mic. And then on the right here is?
I'm Andy Glover. I'm also at Netflix. I run delivery engineering. Cameron's on my team. Well, there's a couple of other people in the audience. Happy to be here.
So I want to thank you guys for coming. This is really, really great. These guys are rock stars. These are people that have been in the field, that have made it work despite sort of the circumstances. So it's really an honor to have them all here on stage, assembled before you. Thank you guys so much. I just want to get a quick round of applause for these guys, because hopefully this will be awesome. I remain your humble servant, Josh Long. I'm the developer advocate at Spring. What we wanted to talk about here, one thing I've seen in a lot of my travels, when I talk to customers, when I talk to users, is that people build very, very amazing things. And as often as not, they take Spring as sort of a very rich base, but still just a base. They layer things on top of that. And that's usually to sort of create some sort of conformity in their organizations. They want to have a framework on top of the framework that serves their particular use cases. When Spring Boot came out, there's an opportunity there for organizations, far and away to standardize upon that, to build these service templates on top of that. And we've seen some incredible results just in the last year. I mean, remember, we debuted at large Spring Boot here last year, right, at Spring One. So the results have been amazing, and these people represent engineers, top of their fields in very large, very, very high scale use cases. So what I wanted to do is sort of, let you understand what some of these guys are doing with Spring and Spring Boot at scale, what customizations they've done to the framework, what they used to use, maybe, if they can shine some light on that, that'd be nice. And then just we'll give them 5 minutes, 6 minutes, I don't know, whatever they need. We'll give them a few minutes to kind of introduce themselves. And then we're going to go into sort of a discussion, right? We've got a lot of points we can speak to. And during that time, we would love to have your questions. And I'm going to run around like a chicken without the head and give you a mic if we need to. So is that OK? Can that work? OK. So first things first. Who wants to go up first? You're closest to the monitor there, Mr. Barlow. We have this very awkward. I was wondering if we could steal the chaise from outside and just bring it here, but oh, that's so weird. Resource contention, not a good thing. So, by the way, if you have good comments, bad comments, hate mail, feedback, we have a lot of Twitter accounts there. Those are our coordinates. Please feel free to reach out to us. We're always happy to answer questions. If you leave this room more confused than when you entered, now you have recourse, right? So reach out. All right, take it away.
Awesome. Well, thank you very much for the intro, Josh. It's a real pleasure to be here at Spring One. And I'm going to tell you a little bit about Ticketmaster. And the reason that this is important is because, and as I will show to you all, our history is pretty storied. And I think when you see what I have to show to you guys and we kind of go through our demo, you're going to be pretty interested to see our transformation. So we are a 40-year-old technology company. I don't know if you all knew that, but we're pretty old. And whereas we do about $16 billion in revenue, we have thousands of clients, millions of fans, millions of app downloads. I hope there are some folks in the audience that have our apps. And in our biggest on sales, in our biggest traffic times, we do about 20,000 requests a second on our consumer-facing websites. And that tends to be sustained for about an hour. So that just kind of gives you a sense of the scale that we operate at. And you might be thinking, well, how does this apply to Spring Boot? Why is this relevant, right? Well, so we've been doing this for 40 years, right? Services should be second nature. It should be super easy for a Ticketmaster engineer to go from idea to data center, right? You would think we could do that in a couple of hours. We've been doing this for 40 years. That should be really easy. Decades, right? So since around the early 1980s. So in actuality, that's wrong. It's not that easy for us. We're getting there, and we'll lead you through our demo, which shows you the strides that we've made. And it's a continual evolution for us. We're still trying to get the perfect recipe. And we have all this legacy lying around in our company like you wouldn't imagine. So let's rewind the clock a little bit. Let me show you why it's so challenging, right? And this is some of our legacy hardware. This is our VMS VAX system. And in case you can't see the retro logo, I'll kind of zoom it in a little bit for you. And this software is still running today, right? This is our operating system, right, from 1990. There are versions older than this.
Yeah. I feel for you. Exactly.
I just got someone apologizing in the audience. I'm sorry, was the quote. And I really appreciate that. So the host is who you just met, and it's still running today. When you buy a ticket to a concert on Ticketmaster, your ticket gets generated by the host. Okay, I'm embellishing a little bit. It doesn't quite still run on the same hardware. It's on emulated VAX now. But it is true that that software is still running today. So this is our big challenge at Ticketmaster. We're dealing with all this legacy, and now we're trying to get super fast from idea to data center. Our board invested $100 million in replatforming our ticketing platform. We have somewhere between 15 and 17 different ticketing platforms, and we're trying to consolidate them as we go, and the board is investing in that. So we're trying to meet the board's demands, and we're trying to be fast from idea to data center without sacrificing quality. And as we walk through our demo, you'll start to see how we're going about this. You want to stand up and join in the fun?
So, one of the things that we've had a Spring group, we've had Spring internally on like an X.
You have a microphone?
All right. We've had
Give me the
can you hear me now?
We need the microphone anyway, so.
I've got it.
Oh.
Can you hear me now? I'm getting shakes from the back row.
Why? Is it on? It's got a green light. It's got a green light. Okay, that's awkward. Here, switch.
Okay.
Resource contention.
How about now?
Whoa. Whoa there.
Are you deaf yet? All right.
Now.
Yes. Okay, so one of the big challenges that we had is in the effort to scale up from our legacy platforms to to a Spring-based stack. We've had some Spring projects. The mobile API, which is a project I work on, was the first Spring application internally. But we've had a number of development groups internally scale up all at the same time. So imagine trying to build a development culture where you have 15 Scrum teams starting from scratch, not talking to each other on day one, right? So one of the big challenges for us has been scaling practices and scaling culture, right? Most dev teams start from a small nucleus and then kind of accrete and then build out from that. We had all of the dev teams essentially start the same day in disparate offices all over the world. And all on Java, all actually pretty familiar with Spring, but all wanting to do things different ways. And so what we ended up with was our first SOA architecture that runs some of our software had a kind of, there was no homogeneity, and everything was a little bit different in strange ways. So one of the things we did is we did our own, whenever we moved to Spring Boot, we built our own example of start.spring.io. And what this is a way for people to start from, I want to build an application and have a common way of building that, a common template that will run in our, with all of our conventions built into it based on the Spring Boot template. So this is a lot less feature than the start.spring.io, but what it does is it allows us to very quickly enter all of the information about you as a service group. My team enters this. It talks about, this integrates with our technical operations center practices whenever he's entering the email notification. It integrates with our GitLab internal instances. It integrates with pretty much everything. You click a button, and it allows you to download a zip file. And that zip file is a application starter template. So one of the most powerful things about this is this allows us to get very quickly to a real production runnable app for everybody without everybody making different decisions on the way that they start. And this is a really powerful thing for us. One of the most important things that we had, so Rod is currently just unzipping the
Can you see that, by the way?
The demo app.
In the back? Do you want to
Okay,
command
good.
++?
So one of the most important things we had is, again, coming from a legacy stack, they had used Ganglia and some older tools to instrument that app stack. But whenever we went to a new Java stack, there really was no tooling internally for visualizing app response times or monitoring or any of that kind of stuff. So early on, we went fully in on Splunk, which is great, and we still use it a lot, but we didn't have a real-time monitoring and alerting solution with graphs. So one of the first things that we did is we built a platform for auto-instrumenting running applications with graphs, so that from the second that you started up your Spring Boot application, you would get integration with all our monitoring and logging applications. Now, Spring Boot provides a lot of infrastructure for this, but we were using OpenTSD, and I don't know if you, and Rodney's going to show this in a second, I don't know how many people have used OpenTSDB, but it has kind of a different model for the way that it does metrics.
How many of you have or have heard of it?
OpenTSDB?
A couple people? Wow.
So OpenTSDB is very, unlike Graphite, which is very much this kind of hierarchical data structure, OpenTSDB uses tagging for how you do monitoring. And a lot of people who have used OpenTSDB do not adapt to tags because most metrics frameworks don't speak in a tag language. So we did an adaptation to tagging, which works very well. Rodney's going to show you an example as soon as he gets this. So if you look at this, he's running on, he's just set up his Spring Boot application, and you want to share the Netcat screen? So this is a screen where he's listening to a UDP port on Netcat. And what this is this is a push of all of the metrics that are being logged to OpenTSDB out of the box for this application. So Spring Boot does provide a lot of instrumentation for metrics, but they're not based on tags, and this is all based on tags, and it's also based on push directly to our OpenTSDB infrastructure. So this just looks like a wall of text, and it's kind of difficult to see what's going on here, but it's got JVM metrics, it's got like you can see the GC metrics, the heap size, the thread statuses, and all this kind of stuff out of the box. And the key thing here was to try and get everybody in the organization to be on this stack, because we have a really great open source tool, which you can go find on GitHub, called Metrolix. And Metrolix is a visualization tool for OpenTSDB. OpenTSDB has really, really great metrics and monitoring stuff, but it's a little bit weaker on the UI side. And so this is an open source, very rich JavaScript UI, which allows us to visualize our metrics. So what Rodney's showing is here, this is our API's real-time metrics, which are all based on this out-of-box approach. And one of the things that's great about the Spring Boot, these are all metrics that we have internally based on auto-instrumentation. Our Spring Boot instrumentation is such that it goes in and auto instruments your JVM for JVM metrics. It instruments all of your RESTful endpoints for request times, exception counts, histograms for exceptions, and all this kind of stuff. So here's memory pool graphics. And it allows you to cross-cut your metrics any way you want. I want to look at this cluster. I want to look at this box in this cluster. Now I want to look at all of my clusters, but only the first box, because that's where I did my canary deployment. And it's a lot more flexible in the kinds of ways that you can cross-cut and graph metrics than some other platforms. So this was kind of the first thing that we did. This was the way that we got a metrics culture internally. Because again, a lot of what we're doing is scaling culture as much as we're scaling applications, because we want everybody to at least have a common foundation before they fork off in different directions. And so having a common way that we learn how to do metrics is really important. And the way that we implemented that is that, again, all of this stuff is auto-instrumented. So if you hit one of the endpoints, so this is...
Can you see that? Command ++ maybe? Oops. There.
So like this is the root endpoint, which is, again, auto-instrumented from the code in Spring Boot. It goes through and it looks up all the RESTful endpoints and builds that kind of Hadios-based home page for your application. If Rodney reloads this real quick and then goes back to the metric stuff, the Netcat, you can see now that all of at the bottom there, it says resource exec time timer millis. That's all stuff that shows how long it took to access root, and with the histogram for TP99 and all of that kind of stuff. So all of this stuff comes out of the box. Again, Spring Boot provides a lot of this, but we had to adapt to our internal OpenTSDB infrastructure. So this was kind of an add-on.
Can't fix what you can't measure.
Right, exactly. So this is a way for us to drive that metrics culture. Couple more things I wanted to show. Again, like I said, we have that Hadios homepage that we've instrumented off of the way that we do that measurement, though, is we use the Spring container quite a bit. We do a lot of introspection of the container. It will do things like reach into the container and say, find all my caches, both like, it kind of has an escalation strategy. It'll say, find all of the EH caches. Now find all the Hazelcast caches. Now find all the memcache caches. You have other caches that I can only recognize as Spring cache. OK, now find all of those. And it has strategies for instrumenting all of those, so you can do things like count your hit-miss ratio, and it will get to the deeper levels if you have deeper cache. Like EH cache has a lot of very specifically instrumented metrics. It also does the same thing for DB connection pools. It does the same thing for a lot of different frameworks. It goes in and uses the Spring, the Spring container to auto-instrument the Spring container and look up stuff and auto-measure it for you. Because we have a lot of people doing a lot of different things different ways internally, and we're trying to, again, reach in and do all this for them. And then this is an endpoint that we added that shows you all of the things that you're measuring. And then if you look at the tags and values, that's so that you can look up how to find these metrics in OpenTSDB. Because as I said, OpenTSDB is very tag-driven as opposed to hierarchy-driven. And so having that as a way of finding finding all of the tags by which you can cross-cut metrics is really important.
Wow.
So that's again an out-of-the-box solution. That auto-instrumentation metrics package currently is internal, but we're in the process of open sourcing that. So again, the idea that you can have a single jar that you drop in and that auto-instruments all of the different things that you want to measure, and then allows you to export that to, right now it's all based on Codaholly, the Codaholly/Yammer metrics package, but we're building an adapter to the Netflix OSS Servo platform as well. So I'm very excited about that. I like Servo a lot because Servo has tags as a built-in first-order concern, rather than Codaholly metrics where I do kind of silly string concatenation and put it in the registry that way. So
cool.
Yeah, I think we're good.
I have a question.
Yeah.
What do you guys use for alerting platform?
So, yeah, the question was, what do we use for alerting?
Bless you.
The biggest thing that we do for alerting is that we split out the same metrics that we do for our OpenTSDB solution. We have a wrapper around the T-collector, which is TSDB's way of taking the averted metrics and pushing them in T-collector. We also push those over to Zabbix with a filter. And then we have a thing called Zabbix.xml internally, which talks to the Zabbix API and auto-configures alerts. So I have a run deck job that has a Zabbix.xml. I change the XML, I push a button, it pushes it to Zabbix. And so I can update in real time all the thresholds for my metrics. And then it sends alerts via all the different alert metrics methods that Zabbix has.
It's awesome. Other questions before we go on to our next intro?
So much time.
OK. Now up, Andy Glover. I'm going to get out of your way. Netflix's Andy Glover. Thanks, Rod. Whoa. Like 4 things just fell. So in the meantime, can you tell us a little bit about how much collection do you do every day of metrics? I mean, do you have
so when I
OpenTSDB scale?
I mean, I don't have the numbers for how many metrics we push with OpenTSDB. Billions? Yeah, so Rod just said billions of events per day, which sounds about right. I know that whenever the systems team started with OpenTSDB as a way to measure their OS level metrics and their systems level metrics. And so we wanted to have a single pane of glass solution. So I didn't want to go and say, OK, now we're going to use Ganglia to do application metrics, or we're going to use some other platform. We wanted to have all the things. So I can put, here's my CPU usage on the same screen that I can put, here's my application response time. And I can say, oh, well, I just had a huge uptick in CPU usage. Where did that come from? Or what? Even down to the endpoint level, I can say, oh, we just had a gigantic uptick in the number of people hitting this endpoint, and that's caused CPU to go, or that's caused database to go, because you can look at correlations in a single graph. That's where the billions of metrics come in. And then the request per second for us in terms of the number of metrics, I know whenever we started over, it was in the hundreds of thousands of individual metrics gathered whenever we started on application metrics. So it's way above that now.
OK.
All right.
All you.
All right. So as I was talking about on Monday night, Velocity is a killer app. And I wanted to tell you all, I wanted to expand on that a little bit more from the context of Netflix. So as I talked about, Velocity is as the killer app, and speed is a competitive advantage. And Netflix feels very strongly about speed and the corresponding competitive advantage we get from that. Because as you're all probably aware, anyone can stream some video. In fact, InfoQ is going to be streaming this video soon enough. So the special sauce of Netflix is the data that we gather about the experience of that video, watching that video, and the ability for us to rapidly change the experience for our customers is our competitive advantage. So something we've talked a lot about at this particular conference is obviously boot and microservices. So I want to tell you a story. With that in mind, keeping in mind that Netflix uses its speed as a competitive advantage. Yes? You gotta be kidding me. Thank you. All right. So the monolith app. There was a time long ago that Netflix was essentially Netflix.war. Netflix was a monolith app that went down from time to time. And a number of years ago, a strategic decision was made to do 2 things. 1, break that monolith up into a series of services, those being discrete, isolatable services, and 2, move to the cloud. And why do we want to do that? Well, why would you take a monolith and break it up? Well, the number one reason that people fairly often don't mention is this whole idea of loose coupling, right? We've been talking about loose coupling for decades when you think at a micro level of your code, right? And the same thing is true at a macro level. And in fact, the whole notion of loose coupling is arguably why Spring is around, right? IOC and Spring. And again, at a micro level, it's unquestionable. We want isolated pieces of functionality. In fact, we take God classes and we break them up. We refactor them using extract class. And the same notion is true at a macro or an architecture level. You take the monolith or the God app and you break it into micro apps, so to speak, or microservices. And so you get loose coupling, and of course from that you get easier testing. It's a lot easier to test these services in isolation. And then another awesome benefit is parallel work streams. That is, rather than doing obviously this big bang release and coordinating amongst everybody in the room, people can work in individual work streams and knock this stuff out. So we've been talking all about how great microservices are, and we'll get to how great boot is. But I need to tell you, and I'm sure everyone here is aware of this, that there are no silver bullets in the software industry. And
but you promised.
I didn't promise.
Damn.
And in fact, microservices are not a silver bullet. They come with some caveats. So let's talk about some of those. So first and foremost, breaking up a monolith into a series of services has huge operational consequences. And so first and foremost, if you're going to go this route, if you're thinking about looking at microservices, and I'm sure the good folks at Ticketmaster can attest to this, you have to have you better have you better invest heavily into automation and testing. And think about this from the standpoint of automation. With one app, if you want, let's say, high availability, you take that, that monolith, that, let's say that Grails app or whatever it is, that war, and you deploy it on 2 nodes, right? And then you put maybe a load balancer in front of it. So you've got 3 distinct, let's say, nodes you got to deal with. You take that one app and you break it into 4, and if you follow that same pattern, all of a sudden you have, what, 16? 12. You have 12 nodes you have to deal with, and that's just having high availability with 2 nodes. At Netflix, we have services that run in the thousands of nodes. So if you're not automating or thinking about automating how you're going to handle the operational aspect of even just deploying microservices, you need to start there. In fact, you might even be better doing the monolith if you don't have this automation in place. Where's Billy? Is he here? Second, it does require a culture change. And I know this is not a culture conference, it's a tech conference. But I want to explain one thing about Netflix that is interesting, that at least for me, took a little while to understand. When you look at a microservice architecture, taking software and throwing over the fence might have worked when you had the monolith. It no longer works when you have a bunch of them. And in fact, at Netflix, there are no ops teams. Each software team that builds a service is in charge of deploying that service and maintaining that service in production. If something breaks in that service, i.e., if one of Cameron's services breaks in production, he's the one that gets the phone call. There is a reliability team in Netflix that watches this stuff and ensures that, hey, okay, we noticed a dip in some sort of metric, but they're not charged with fixing that service. Cameron is. So that's a big culture change, and that's, if you think about it, you have to go that route. Once you take a big monolith and all the, let's say the infrastructure and the operations around that, you break it into a series of small individual services, essentially your ops team dies. They go away, or they migrate into those dev teams. So I'm sorry if you are an ops type person. You need to find a home with developers. That's the whole DevOps culture, right? Something else to think about is, as these guys attested to, is monitoring, right? Monitoring one app is easy. Monitoring hundreds of apps is a very big challenge. Fault tolerance, resiliency, availability, service dependencies are a huge concern in a microservice architecture. How do you effectively handle a request? Think about this, right? In the monolith, your contracts, so to speak, are binary. Like this class talks to this class. You take that monolith and you break it up into a series of services. Service foo, service bar. Now foo has this dependency on bar. What happens if bar has latency, or worse, bar goes down and someone's requesting something from foo? How do you handle all that? These are big challenges and concerns that you are going to have to think through if you're looking at a microservice architecture. Service contracts, right? Again, 2 objects talking together, binary in Java, just message passing. Fairly easy to know when something's broke, something doesn't compile, right? Once you go to HTTP and JSON, and then you have teams rapidly moving, you have to come to some sort of agreement on those service contracts, or things are going to break once you deploy it. All that being said, I'm not trying to scare you away from microservices, because the good news is Netflix has solved a ton of these problems. And we've open sourced a lot of it, and there's been some great talks. Spencer and the crew at Spring have integrated a lot of these things. And that's why you'll hear these projects like Hystrix, right? That problem I was talking about with foo talking to bar. Hystrix is your savior there. If bar starts having some problems, Hystrix can help you out. Eureka, service discovery. How does bar find foo? Especially in an architecture where foo could be distributed across 1,000 nodes and you want to talk to, what's the instance of foo I need to talk to? You're not going to hard code that stuff. You're going to go to service discovery. There's other ribbons, or ribbon I should say. So Netflix has solved a lot of these issues and we've open sourced them. So I highly recommend you look at the good work that the Spring folks are doing. With respect to solving some of these service discovery and whatnot, other issues that microservice architectures bring up.
Spring Cloud.
It's called Spring Cloud, forgive me. So how many people here are a Netflix customer? Awesome. Thank you very much. We love you. Chances are you're already a customer of Boot. Boot is leveraged across the enterprise at Netflix. My team is doing delivery engineering, but there are other teams at Netflix who in fact had adopted Boot before we had. Billing and payments, so there's a good chance if you are a paying customer that your request may have been fulfilled by Boot. And in fact, one of the developers there, Taylor Wixell, is in the audience. Hey. So if you have questions about that side of the house, feel free to ask him questions. So why did Netflix adopt Boot? What's special about Boot? Well, first and foremost, the whole actuator framework is phenomenal. That operational aspect of Boot, right out of the box, health checks, metrics, even just security and whatnot, those come out of the box out of Boot. Perfect. Externalized configuration, kind of a no-brainer. But again, being able to decide your configuration based on your environment and externalize like YAML file. Spring 4. Everyone here is a Spring fan. Spring 4's got some awesome features, some annotations. My team, we make heavily use of the conditional annotations on top of Boot because, again, the stuff we're building right now is not open source, but it will become open source. And there are open source components that are different from our internal ones, so we need to have specialized, essentially, conditional annotations that let us know if this is available, use this. If this isn't, use something else. And I can show you that later.
That's the basis of Spring Boot's auto configuration.
Exactly.
Conditionalness.
And then the build system, the fact that we can, we get essentially everything in Gradle for free with respect to Boot. We basically just say Gradle, Boot, run, and we've got it, and it handles all the fat jar. No problem. It's Netflix. I think you haven't paid your bill. So maybe we can talk about this later. You had asked a question about how.
We'll come back to it.
We can come back to it. Yeah, so.
Any questions?
We'll come back to that.
Ponders?
Questions, comments?
Yep.
So when your development teams are also the people who have access to production.
Yeah.
Do you run into any problem with separation of responsibilities, regulatory compliance?
Sure. So the question is if your developers are the same ones that have access to prod, do you have regulatory concerns? And what was the other one?
Well, just so if you have sensitive data out there, how do you ensure that the people who have access to it are not the people right?
Yeah. So we have different environments. Obviously, as Taylor can tell you more about, PCI compliance and SOX compliance has some restrictions there. So in his side of the house, for instance, I am not allowed to go on those production machines, and that's arguably the correct thing to do. In fact, not arguably, it is by law the correct thing. But where there are no concerns about PCI or SOX, Netflix treats us all like adults. If I go into prod and I screw something up, I will be held accountable for it. Either we'll fix it quickly and learn from it and realize that, hey, you shouldn't go into prod and remove the root partition. Or if I do something devious, I will be let go. And the same goes for anyone at Netflix. So we try to, it's in many ways controlled chaos, but we trust our engineers, do the right thing, work, act in the best interest of Netflix, and to date, it has never bitten us.
So that's a benefit of the microservices approach. You break the monolith up in only small parts, or no sense to.
Yeah.
So repeat.
You were saying it's a benefit of taking the monolith and breaking it up in that individuals can work on these things in isolation. Certainly.
I wanted to weigh in on that as well. I mean, we actually have a problem with that same thing historically. Two things about that I would say is know the actual requirements of PCI and SOX, because a lot of times you'll get a lot of FUD. This is not possible because of PCI, or this is not possible because of SOX. Have one or more people who actually know what that means, because a lot of times there's, there's a book, The Phoenix Project, and it talks a lot about distinguishing between reality and fiction where those things are concerned. Yeah. We do have that problem, and one of the ways that we've solved it in terms of breaking up the monolith is also breaking up, again, the environments in breaking up the monolith, so that, and we've used Spring for this as well, and saying, this is the PCI zone, it's a much smaller, more tightly controlled zone, and everything else is in the free-for-all zone, so that I can access your service. That's been a huge change.
Yeah.
Oh, that's very cool. Another question? Two?
Do you do anything special with shared libraries? Once you've got your teams broken up, if there's code that wants to be shared between those teams, how do you deal with that?
So I'll answer for, obviously, Netflix, and then you can answer for, do you want me to sit?
Yeah, panel time.
Panel time.
Question and answer. Like, this is the rest of the show.
So the question is shared libraries, and certainly Netflix has cross-cutting concerns that we would want to share those libraries. And there is a platform team at Netflix that builds essentially the Netflix platform that all of us make use of. And they do regular releases, and you pull those in, and it gives you access to shared, access to discovery, which is known as Eureka, access to logging and whatnot. Essentially, all the cross-cutting things that, regardless of what your app does, you would want it in the environment.
So if you want to change that, you just submit a pull request?
Certainly, you could do that. It's an open culture. You could do that, or you could go talk to one of the engineers and say, hey, this is what we're looking for. And sometimes they can turn it around quickly. Other times, you do it yourself. You submit a pull request.
Cool.
I wanted to kind of weigh in on that. We're very much adopting the same model for a very long time. We've been, very siloed. We're trying to follow this sort of more internal open source approach, that there are committers and that there are, you can submit a pull request, as you said. Rodney's actually the head of the platform team as well. And again, their job is to, the metrics library that we showed, I developed it for my team, and then kind of slowly handed it off to the platform team, and so now other people can make contributions in the wider space. So.
Cool. Yeah.
So you were mentioning that basically when you go to the distributed model, the ops team kind of gets absorbed into the dev team. What about in terms of hardware ownership? Obviously, Netflix uses heavily the AWS. If that's not something that a company's doing, who would you say should own the hardware? Should it still be pushed down to the dev level?
The question was, who owns the hardware in a case where your deployments
my answer would be the devs, but
I can weigh on in this. I mean, imagine that your hardware, your systems team is AWS. That's kind of the model that we're adopting, is that they are the cloud platform team. They provide the tooling. Their job is to turn the hardware that they rack into cloud infrastructure and give us AWS-like tools to deploy on that. Again, we're adopting this. Like, my team provisioned their first QA box. It's like 2 weeks ago. It was a super exciting moment for us, because it gets us into the model that they have on AWS in our own data center. So hardware is owned by the systems team for us, but everything from the OS level up is owned by devs.
Actually, that segues kind of nicely into, obviously, I would be remiss if I didn't mention that Pivotal Cloud Foundry is a great way to solve that problem. But nonetheless, even if you're not using that, I think a lot of us have converged upon some sort of cloud-like infrastructure, right? And for a lot of people, that might just be something like a container or virtual machines. After this question, maybe we could speak to that. Do you guys have that in your situation?
I was just going to jump in before you ask your question, and we're moving to an OpenStack-based internal cloud at Ticketmaster, and the next thing we're going to layer on top of that is charging back to the teams, right? So making very transparent to each of the engineering teams the cost that they bear from all of the services that they're running in any given environment, right? So we have teams that aren't being very judicious about the number of VMs that they run or how efficient their services actually are in the production environment. And we're going to help get them attached to that, right? So that they can start to make better decisions.
Visibility.
Feedback loops.
So,
yeah.
So can you guys spend a minute to describe the application structure at a high level of where you guys are using? We're kind of talking
So the question was, can these, our esteemed colleague, esteemed panelists offer visibility into the size and makeup of the applications that use boot in production? Yep.
So I can speak for the components we're building at Netflix. We're building internal tools, so I wouldn't say our usage throughput is insane, but we probably have split out. So for some background, we had a couple of Grails apps, and they were deployed, with redundancy, maybe like 2 or 3 instances of each one in multiple accounts or environments. And we've taken those 2 apps and have split those out into something like 14 or 15 very small services. Each one of those runs 2 or 3 instances. Yeah, so in terms of like the type of data that we're dealing with, this is kind of aggregating information about our cloud presence. So that's kind of collecting info from a number of sources, Amazon, our metrics, infrastructure, to kind of present that sort of unified view of what the cloud looks like for people's applications. And then kind of the orchestration and coordination of deployment operations. So we kind of have a bunch of stateless services that are talking to like our Cassandra infrastructure, our hardware infrastructure, and then on top of that we have some UIs that are just JavaScript and Angular. I don't know if that answered your question or not.
Yeah, that's a good start.
For Ticketmaster, so we're still in the early phases of what he showed, which is the monolith to microservices transition. We're just starting that. And so the first thing that we're doing is when you reserve on a ticket on mobile, you're using a monolithic application. And we are in the process of splitting that out into a boot-based microservice. We also are using boot to power a feature that, with a true microservice, one of our earliest true microservices, which basically we internally call it ICANN-has. It decides some availability restrictions about what features that you can get. It kind of is modeled off the Etsy Features API. So those are some of the first things that we're doing. We're also doing a bunch of internal tooling using Boot already. For internal projects, we had a hackathon where in 24 hours, there was some big data projects that were built using Spring Boot as the UI. But right now, we're looking at probably deploying in the next month or so, the Spring architecture that we have, deploying it full scale with Boot. And then right now, that's the mobile platform primarily. And we'll be moving the desktop platform onto that for at least some of our traffic in the next 2 months.
So is that like 10 customers, a billion, something in the middle?
22,000 RPS peak. So I mean, that's millions of customers. During a good hour, we can make about $45 million. I mean, that's a good. So.
Yes, sir.
Yeah. So there's a question on Netflix RX reactive programming. Is there like a good testing framework? Like how do you test it out? Because I see your open source projects, but there's no exactly any test.
I can attempt to answer that. I've only, done a little bit of stuff with RX. I know there's a little bit of support in the library for building test harnesses, but it's definitely an area that they understand is weak, and it's it's a new programming paradigm, so it brings new challenges, even in terms of like how do you debug when you don't really have like good stack traces and stuff like that. I know there's some tooling being built to give you sort of visualizations of what your reactive like graphs look like, but I don't have a good answer for how to test it other than, the nice thing is you're composing a bunch of functional operations, so you can kind of test those very easily in isolation, and then the composition of those you can kind of run through more of like an integration level test.
Cool.
Josh, coming
can we, let's not do reactor and let's do this offline. I want to make sure we use these guys' time as best we can. Is that okay? Yep.
So how micro do your services have to be before you start to benefit?
Oh, couldn't have paid him. You'll get your check in the mail. Go on.
Yes.
Oh, yeah.
It's a great question. I think how micro do the services have to be until you can start getting benefits
From this architecture.
Yeah, that's a really good question. The service that Dan was talking about earlier, it's called TAP. It's our Ticketmaster API for partners. So it's our public-facing API, and it's 200,000 lines of code. It's kind of crazy if you think about how big this thing is. What's that?
Oh, and it has it's a RESTful service with 300 plus endpoints.
So it's kind of crazy, and the project that we're undertaking is to to verticalize that and to split it out into separate homogeneous web services using Spring Boot. The other challenge we ran into with that massive API is that you have endpoints that cache a lot of data that don't do a lot of requests. You have other endpoints that are high throughput, and really we've ended up with this kitchen sink. And it's very, very difficult to scale it out. It's database bound as well. So what we're doing is a bit of deliberate discovery on that giant service to understand, well, how big should the ideal service be? And Dan's actually described it really well as, you should be able to fit that service model, like what it does, its capabilities, its responsibilities, into your head. And all of the engineers that work on TAP today cannot fit that service into their heads because it's so monolithic. 300 endpoints, 200,000 lines of code. I don't think there's a single person in the room that can fit that into their head. So the way I like to think about it is single responsibility, right? Method, class, service as well. Yeah. So single responsibility at the service layer. And we're struggling a bit with that today, and we're going to use Boot and our service template to redesign that architecture at a very high rate of change without sacrificing quality.
So, with respect to that, the two services, the one service that we have live, that's doing quite a bit of traffic already in production right now, is extremely small, and we have benefits from that. It's essentially a SQL query. Like you can think of it as a very simple SQL query for the ICANN has service, right? The eligibility service for features. So that's a microservice. The other services that we're doing at the reserve service is probably in the hundreds to 1,000 lines of code. It's much bigger than you might think of as a microservice, but it's got a pretty complex job to do. So I think that, again, there's a lines of code metric that you see sometimes, like 500 lines of code. I think that's a very artificial metric. I think it's much more about, what is the unit of change, right? Like if I have a developer that needs to commit something and deploy something, there should only be one reason why that thing changes, one mental box that you fit changes into. And that's really the true rubric, I think, of a service. That's if you look up on Wikipedia, what does single responsibility principle mean? It talks to reason for change. There should be one reason for change. And I think that is the really good arbiter of where you're trying to draw the line, because it is an art, not a science, right? It's not something where there's somebody who says, here's the rule, you can't build a build filter in your build tool that's going to tell you if you have a microservice or not. But you can make good engineering decisions around where are good boundaries, where are good vertical seams upon which you can, saw off a leg off of and so Rod said no one person can fit it all in your head. Peter Frank in the front row is probably the closest human being that can do that. He's pretty much got it all. But he was the one who was making the decisions about, hey, this is a piece that probably is one single unit of the responsibility because he knows the app inside and out, and somebody in your org is going to have to make those decisions.
Anything to add?
I just wanted for us, we're kind of in a bit of a greenfield mode with the new stuff we're building, and I would say we're definitely erring on the side of make it a new service. If there's any sort of question in your mind, make it a new service, because especially with Spring and with Boot, it's super trivial to take two Spring Boot apps and munge them back together with component scanning or the configuration discovery. It's harder if you go down the road of like making something too big to then have to tease it apart. So I think there's probably cases already where we've sort of starting to get this feeling like, hey, I really have to kind of interact with two services all the time to accomplish something. Maybe those should join together, and at some point that might happen. But we're right now err on the side of make it smaller, and if you've got good tooling in place for service discovery and the inter-service communication, then really combining things back together is almost like easy to do after.
Just want to add two more things to that. One, I think is a best practice when you start going down this route is something we've started doing is that we are building libraries and exposing those libraries features through boot. So to Cameron's point, it's very easy for us to combine those two things rather than to tease them apart. One other thing is when we said we had 14, I think someone scoffed because immediately you're thinking, wow, that's 14 different services I have to talk to. Interestingly enough, today I was looking through, I found a website, it was like microservice.io. I think Chris Richardson, I think he was creating it, and he was capturing patterns. And there's a particular pattern that we're employing at Netflix that apparently is becoming a pattern that people will employ or should employ, and that's kind of having a gateway. So at a micro level on our team, we have created a gateway service so that our partners who are using our services don't need to know to talk to X, Y, Z, foo, and bar. They go to our gateway service. And at a macro level at Netflix, it's the same thing. All the devices out in the globe, they go through essentially a gateway, which we call the API gateway, so that those devices don't have to look up and talk to, let's say, something to deal with billing or subscriber or whatever it is. They go through a gateway service that handles that logic. So something to think about from a pattern standpoint.
There is only Zool.
Yeah, and Zool sits in front of that, yeah.
So, yeah, I mean, along the same lines, as part of the, he was talking about the gateway, that's a really important thing for the monolithic breakup, right? We're starting from a gargantuan app. How do you have a bunch of clients in the field, especially compiled, like, we have a bunch of website engineers that are just like, we'll just change it. And we're like, well, we have coupling to external, compiled mobile apps, iOS and Android native apps, right? We can't just snap our fingers and the legacy ones go away. So we have to present a lot of continuity over build changes. And so as we're carving off pieces, one of the biggest concerns was, how do we keep continuity for our clients as we are internally segregating off pieces? And that's kind of the big model that we're using is we're going to have we have a transparent proxy layer that we're using to reroute stuff internally so that from a user perspective, nobody cares if I have one app, 15 apps, and then I decide it needs to be 3 apps later. It's all transparent from the outside world, or it's invisible from the outside world how many services I have deployed. It's a facade pattern at a network level.
I like that. Yeah, yellow shirt.
How do you guys handle security between the services?
Question was, how do you handle security between the services?
So for us, right now, we handle it by not having security between the services.
Oh.
But there was actually a really good OAuth talk that I went to yesterday that Dave Sire gave.
OAuth.
We need security in order to support the environments where there is the regulatory needs. So it's on our roadmap to figure out what we're going to do. I think we'll end up probably in something like certificate based, just because our security team has that infrastructure to make that easy for us to do. But
so mutually authenticating,
yeah,
kind of thing. Okay.
So we were in the same Dave Sire talk, and Peter and I were sitting there checking off as Dave was mentioning different kinds of security. Every single one that he mentioned, we use currently. We use it at the network layer. We use certificates. We use security. We use custom authentication. We use OAuth. We use everything. Okay. And because it's Spring, we have plugins for all of it that we can switch out on endpoints and backends, right? So that's the answer that we have is whatever you got, we got it too, and we have adapters for it. So it works out well. We want to simplify that, but we're currently at everything.
Yeah.
Follow-up question to that. So do you guys use
So the question was, do we identify who is using our service? And absolutely, we actually have essentially two principles at any time. We have the application that's talking to us and the user that's talking to us, and so we need both. We use Spring Security internally to do that. We have, hey, you're the Android app. You're not only the Android app, you're the New Zealand Android app, and you can only access New Zealand resources, right? And then you're a human being, and you have to have a different set of you can only access your account. Nobody else can. And the New Zealand Android app and the US iPhone app have different principles, right? Have different capabilities. And we use Spring Security internally to do all of that work. And then down at the layer below that, we actually use that as a way to dereference to different internal certificates so that we can talk to different back-end applications. We use it to provide different switches using the grants in Spring Security to do grants to different applications. So we pretty much have the entire gamut of not only authorization, not only authentication, but authorization for different kinds of resources internally.
Scopes, no auth, grants, authorities, it's all the same idea.
Yeah.
Yeah. Wow. Was that kind of speak to your question? Oh, yeah, Netflix, please.
Yeah, the Netflix side, if you don't have security, how do you identify who is accessing your service?
Yeah, so to be clear, the services we're building right now in our team don't have security. Netflix, and you mentioned we have a platform team, and that platform specifically provides facilities that sort of propagate the end user of the system through all of the services. So you can tell what customer actually originated a request as it flows through the whole service chain. But
I don't mean customer, I mean more like other services that are accessing. So upgrade paths and stuff.
yeah, that's actually a tricky problem that we have in terms of like upgrade paths. Most teams actually produce like client libraries to interact with the services that they provide, and it then presents a sort of dependency hell challenge as you try and push that forward. There's a couple of initiatives that we have underway. One is making the clients to the services much lighter and thinner, so very restricted in terms of like what you can bring in as dependencies to produce a client library. The other one is actually integrating instrumentation into our build process to kind of give us analytics into the dependency graph so that we have insight as to what's blocking upgrades and who depends on you and how you can upgrade. That's mostly at a like Java dependency level as opposed to instrumentation level. But then there is with AWS, there's also the like app-to-app security management. So that's kind of baked into the infrastructure there. You know who has access to call your application through that as well.
One upgrade path for us is definitely not a security concern. It's a build and testing concern. What they're talking about with build instrumentation. One of the things that we've used Spring Boot to do in our newer boot projects is that the Spring Boot archetype that we chose has built-in BDD test using Cucumber. Like out of the box, you get a project that does Cucumber BDD testing. And we've integrated that with Rod's team, the platform team has actually integrated that with our Jenkins server. So you check that project out, or you download that zip, you check it into Git, it fires, or GitLab, which is our local GitHub alike. It fires a webhook over to our Jenkins server, which says, now build a Jenkins project using this archetype. And the archetype includes a BDD test cycle, which points to our integration environment. So, or in one of the build pipeline stages, it points to the integration environment. So the idea is that if somebody deploys a service that will break your BDD tests, and if you're writing good BDD tests, you have like a migration path like breakpoint at which if somebody deploys a service which is not integrable, your build will fire during a nightly cycle or next check-in, and it will immediately show the break, that the break happens and your build goes red as part of the integration pipeline. So in that way, even though it doesn't solve the problem of an integration path, it does solve the problem of an integration breakage with a contract change getting into prod with nobody knowing. Some build will go red somewhere before it gets into prod. And that's, again, part of the Spring Boot integration is that we've wired all that into the Spring Boot archetype using Cucumber so that it's brain dead simple for a developer, even a developer who's never done Cucumber testing, to have a basic model for doing this. And we built it into our build pipeline so that it's just part of what you do, and you kind of can't get away from it unless you try really hard. And then you get let go.
The gentleman there?
So when you're working with a large network of services, a lot of times it can be very challenging to try and diagnose where a particular problem may occur. What has been the hairiest problem that you've seen, and how have you diagnosed it?
So the question was, given a large network of services, it can be hard to isolate where a problem's occurred. What's the largest one you've seen, and how do you diagnose it? Is that right? Yeah. I don't know.
I can sort of attempt to answer that. I think some of the tools that help address that, I think, are like Andy mentioned. Hystrix is a library that we have that really tries to isolate failure in the service graph. So one service doesn't propagate that failure all the way through the network. The other thing that's really important is, I think, good insight into your services. So we've got a pretty comprehensive metrics collection and dashboarding and alerting infrastructure. The hairiest problem I've seen, we recently, luckily this was only in our test environment, had a very low level component of our application stack that is kind of responsible for our distributed configuration. There was a really old legacy piece of that didn't understand a data format, and it basically toppled over everything. How do you diagnose that? I don't know. Basically,
a lot of hard work.
A lot of hard work, and then
Sadness.
Dan getting on the box and cracking out his Perl skills. I don't know.
I've got two really important ones. Like, one of them was we had an application where things had been running very, very well, and then we had this sort of Schrodinger's problem. The more we measured it, the bigger a problem it was. So we were
cats.
really, what's that?
Darn cats.
Yes, darn cats. We essentially had a service that had invisible latency. It was on the order of like seconds of invisible latency. You're making a request between applications. None of the applications register a problem. They're all like, end-to-end service metrics was like, I'm fine. Even at the level of, I have an outbound connection to this thing, like I'm talking to a service on the back end, even though we say, we were talking about we have a megalith. We do have a very large application, but we still have on the order of 30 integration points. So we're kind of have a lot of internal microservice experience, even though we're on this megalith. So we were trying to diagnose, and the way that we diagnose is that we just got finer and finer grained metrics and better visibility. The funny thing is, as we did that, the problem would also get worse. What it had boiled down to was that they had, whenever we had introduced Splunk integration and OpenTSD integration and started to use them more, they'd rack the boxes in the same vertical racks in the data center as the DNS server. And so every time we were hammering it with more metrics, it was saturating effects at the top of the rack, and suddenly all of the DNS were retries because TCP traffic, which is what a lot of the metric stuff uses, some of it is TCP, gets priority over over UDP packets, which is where DNS lives. So everything was slowing down in an invisible way because DNS was taking seconds to resolve as it was doing zillions of retries. And so the way that we got around that was having better and better metrics around everything to narrow the gap. But again, that had the hilarious catch-22 of making more traffic on effects, which makes more packets drop. So it was kind of by process of elimination, and that was all about visualization, which is why we got very hardcore about putting metrics in all of our services. That was kind of the break point at which everybody's like, oh, I can see why this is valuable for people who weren't kind of already bought into the metrics culture. That was like that was a big night for me. The second one was we had some really, really thorny problems with caching. We have, we have kind of, there's a saying that like there's only 2 hard problems in computer science, and one of them is naming, and the other one is cache invalidation. So we got
and counting, yeah, which makes it 3. Well, I don't know.
Off by 1 errors.
We got pretty deep into having to have very specific cache strategies because Ticketmaster and on sale goes from 0 traffic to all of the traffic in literally a second. So you have these real discontinuous things, but at the same time, the reason why it goes from 0 to infinity is because data that was not available at 659 and 999 milliseconds is the data that everybody cares about at 1 millisecond after. And so we had to be very, very specific in our cache invalidation strategies. And Ticketmaster's under a continual DDoS attack from people who want to essentially sell tickets on other resale platforms. And so one of the things that so we have this sort of bunch of bad actors that are attempting to do bad things on our system at all times. And so we had to be very, very careful about how we do that to deal with a huge influx of bad actors as they started shifting their patterns to try and commit new bad acting, right? And the way that we solve that problem is continuous delivery, right? So having a Spring platform, even though it's a monolith, it's a Spring platform, and then having a good delivery pipeline and being able to adopt the DevOps culture allowed us to do a delivery a day. And I mean, for some shops, that's actually a very small number, like, there's that 10 deliveries a day kind of thing. We're still at best in 1 delivery a day for our team. We're ratcheting that up, but having the ability to deploy very small changes very, very quickly allowed us to step from, we have a very simple kind of dumb cache strategy to we have smarter and smarter cache strategies over the course of a week. And we went from a time where huge influxes of broker traffic were causing system outages and problems like that to no problems at all in the course of like 7 days.
Wow.
So.
Oh yeah, sorry, buddy. You.
You had to rethink how you're doing transactions into a microservice architecture. You have to coordinate a transaction across what type of problem is that?
So the question is, what does the microservice architecture imply for transactions across multiple contexts, and how do you rethink it? Who wants to go first? You want to?
I can take a stab at that. So for us, I guess a transaction is an orchestrated deployment. And that just really means like the persistence of that being durable, the execution of it being something that is resilient to services going away and restarting. So for that, actually, our orchestration engine, we're leveraging Spring Batch and persisting into a Redis instance that our cloud data engineering team has got set up as highly available. But yeah, I think really it's all about you can't hold the state of the execution of the transaction in memory of the service. It's got to be something that is built around running, doing a small amount of work, persisting its state, and then resuming and carrying on, and that should survive across a service restart.
I mean, for me, like the transactional thing, a lot of it is about restful design, like pretty good pragmatic RESTful design. Most transactional systems are very RPC-like. Do this thing, and if you start to think in terms of resources, like this is, maybe for some of you, this is like very 5-6 years ago. I wish that all transactional systems in our company worked that way, worked with a very RESTful model, because then the question of how do I handle a cart, how do I handle a ledger, how do I handle a transaction, are all simple REST calls, and everybody outside of that can, and then orchestration can be pushed up or down the stack. Things like how do I maintain the state of a cart are really easy to do because the cart's just another resource, and whether it's backed by transiently by Redis or persistently by Redis or whatever is kind of a non-issue. And then the outside world has the same kind of instrumentation and monitoring around cart states and all of your transactional metrics like conversion rates and all that stuff are available at a systems level and not just at a like, hey, all this stuff shows up in Omniture. And that kind of thing would be the primary thing for us. We have a very interesting system in that essentially all of the transactions, he showed that VAX slide, all of the transactions that you do in Ticketmaster. One of the things about Ticketmaster is we are on a strictly first come, first serve basis. If you show up first and you show up second, no matter how many other people are in line, you will get a better ticket than you will if you're doing the best available model, which is, if you think about that, that all boils down to a single point of failure. And so we are very much in the model of rethinking our transactional model into a REST model so that that difficult problem of a literally first come, first service at web scale is faster for everybody involved. So that's kind of one of the rubrics we're using when we're doing that redesign.
Cool. Oh, yeah. Hello.
So let's talk about something like Amazon where you have multiple regions. How do you take microservices and globalize them? What's the relationship of a service to a region?
Question was, how do you take microservices and globalize them across the data centers and so on, Amazon Web Service regions? Oh, you okay? Go ahead and talk. I can show you.
Oh,
he's got to
I
show.
guess, yeah, and he's going to. Yeah, so for us, regions are sort of at least semi-isolated. We do have distributed, our Cassandra instances are sort of globally distributed, which means that you can kind of start something that's persistent in one region and we can fail you onto another region, but it's definitely a deliberate choice we would make, or a reaction to a problem in a region. It's probably the kind of thing that's going to kick off lots of hystrix circuit breakers when it happens. It's not instantaneous or seamless to make that happen. But for us, we do try and specifically we're building the tools that teams are using to visualize their deployment, and so things that are important in that multi-region sort of view of the world are ensuring you've got consistent configuration in each region, or you could say each data center if you were in data centers, and so kind of visibility into the sort of the consistency of your deployment across regions is one of the things that we try and do for the teams.
Yeah, one thing I would add on top of that is, so the question was kind of how you deal with multiple regions in AWS. And in fact, AWS, their model kind of breaks down with that. And so one way of doing it, the way that Netflix looked at it, is the highest level thing you can have in AWS is a bunch of servers, a server group, or what they call an auto-scaling group. Netflix added a model on top of that, so you can have multiple auto-scaling groups. Or you can group those into something we call a cluster. And then a bunch of clusters can be grouped together into an app. So clusters are in regions, ASGs that can be spread across availability zones. And then an app is something global. And so, one challenge with that is how do you visualize that? How do you understand? Did you say this on mic, please?
Oh, sadness. Sorry, my fault.
So I will not repeat what I said to people in the back. I know they heard me because I didn't get up and leave. Yeah, so when you do operate in the cloud and you go global, frankly, the Amazon model breaks down, and that's some of the innovations that Netflix has open sourced. Is to again see that holistically and look at the globe as a globe and not a bunch of different regions. And we are able to infer a lot about how something's deployed based on naming. And like I said, those models on top. Another aspect that feeds into the microservice, I think, mantra, and it was alluded to as some of the answers these guys have given, is this whole notion of state. And the way to look at it is that your microservices should not have any state, and so that you can bring them up regardless of region. Or where they are in the world, and then they can be shot in the head at any given moment, again for that resiliency. So what we're showing here is, here's different accounts in AWS, and these are different clusters. This is just test data, but you can see the various instances in those, this is a cluster that has 2 ASGs. You can take actions on those ASGs. Again, ASG is just a bunch of instances. In this case, it was at 6. You can look at individual instances as well. So once you kind of, I think that the longer answer to that is that you need a name, like a nomenclature on top of that, and then a higher level UI so that you can kind of handle this whole notion of various regions. Wow.
One last follow-on.
Okay.
Follow-on to that last quick. We don't use AWS, but we do have like a partitioned cloud. We have multiple availability zones on a cloud-backed infrastructure internally. And one of the things that we have historically done is when we want to deploy some of the older legacy software, we take one of those availability zones essentially offline, replace the software, and put it back online. As a highly, we're building highly resilient systems, and we don't want to do that. So whenever they take out some of the systems that we depend on, we want our backend to fail over to one of the other availability zones and say, hey, I want to use that availability zone. And so we've been looking strongly at Hystrix and Ribbon as a way to solve that problem. And we saw the Spring Cloud demo in the keynote, and our eyes lit up because we're like, suddenly, whenever we're using these Spring Boot applications and we want to do the Hystrix circuit breakers and the Ribbon failover between availability zones, that's not an original problem to solve anymore. That's a problem that's there for us. So we're excited to go back in our workshop and start working with that stuff as soon as possible.
Wow. So I have a question, and we're sort of nearing the end of our panel here, I'm afraid. So ever so briefly, what would you, gentlemen, recommend in the way of literature, things to look into? What was the aha moment for you? I mean, I feel like one great thing to take away from this is something to read, something to look into. What do you think best defines the kind of architectures we've been talking about here for you guys? And if that means pimping out your own blogs, that's a great, please do.
Google microservices.
No.
Now,
Chris Richardson, yep.
On InfoQ.
That strategy is very much what we're following. And another really smart guy has an article on InfoQ called Exploring Microframeworks, Spring Boot.
Oh, yeah.
Which is another really good one to look at.
So the answer was Chris Richardson's decomposing services for high availability on InfoQ, and then, wasn't that yours? Oh, you.
Yeah.
You.
Are you on Twitter?
No, never heard of this guy. Okay. Yeah. Anybody else? Ticketmaster friends?
This guy had a question.
Oh, what's that? Oh, yeah. No, well, no, let them answer the question. It's just, I want takeaways,
Yeah, so the most of the literature I've read, or a lot of that literature, I think Martin Fowler's Blicky is a pretty excellent resource for this type of research if it's something that you're interested in. There's all sorts of things on there from microservice architecture to using things like, yes, it's a bit old, but XPath to extract only the data you need, to the strangler pattern. All these types of things are on that Blicky. I highly recommend it. That's Martin Fowler. And there's another really good presentation on InfoQ about microservices. I can't remember exactly who it is, but if you Google that on InfoQ, I'm sure you'll find it. It's a really good resource as well.
So InfoQ, we're keen on that. And by the way, these videos, these talks, they're all going to be on InfoQ. How's about that?
High Scalability is a great website. I would follow that if I were you.
You know who started that, by the way? No. They got one of the CTO for InfoQ.
Oh.
I think there's a pattern here. I think we should just InfoQ.
I'll deviate from the pattern and kind of shill for these guys.
Oh, yeah.
The Netflix OSS GitHub account is, it will alert you to problems that you don't know you have, and then tell you how to solve them. Like, we've been struggling with like load balancers, right? Load balancers and VIPs or virtual IPs are like the hardest thing that we deal with in our deployment pipeline to accelerate. And you have this kind of vague idea. maybe we shouldn't be using them. And then you find Ribbit and you're like, yeah, we totally shouldn't be using them. We should be using these guys' stuff. So from my perspective, look at the Netflix OSS GitLab and the Netflix tech blogs, and that's probably the best resource you can read in my opinion.
Thank you. Oh, anything else?
And then there's also the Ticketmaster tech blog as well, which you should all put into your RSS reader or whatever it is you use to read blogs and follow along as we mentioned our 200,000 line code monolith, and as we break that up in these vertical seams and use Spring Boot to improve the scale and improve the throughput, we will be blogging about that. I guarantee you. So follow along.
So thank you for that. I hope this has been helpful. I wanted you guys to. I've had the privilege of talking to the gentleman on stage before. I've talked to a lot of other big customers out there. How many of you guys have heard of Baidu, for example? Baidu is like the 4th largest search engine in the world. That's a giant Spring application. Taobao is a e-commerce application in China as well. These are both Chinese companies, but they have crazy scale. Taobao did 10 million, sales. They did more than $3 billion in sales in a 24-hour period in 2012, which is much greater than eBay and Amazon combined for that day. These are all Spring applications, large scale Spring applications, and they're infinite more, Spring applications of this sort of scale and of the style that we've seen discussed here today. I hope this kind of shines a light on some of that. You guys should know, if you take one thing away, this microservices stuff, this architecture, it's been proven, it's been tried already. This is not something that we are trying to pimp out for Spring 1 just this year. This is actually something that we're seizing upon that has been born in the fire of industry, And what you see here are 4 specimens, who have been making this stuff work really, really well. I want to thank our panelists. You guys should stand up and take a bow. You guys are amazing. A round of applause to these guys.